project, Hiking Trip Planner, is the first project for CIS 571 web services. This project is a web application for a user to plan a hiking trip and to get suggestions of the gear that they should bring on that trip. This application was built using Python's Flask web framework for the backend, which interfaces with a backend MySQL database, and then all the front-end code is HTML, CSS, and JavaScript. The existing APIs I used for my website were REI's hiking project. The two functions were getTrails and getTrailsById, which either give in a latitude-longitude pair for getTrails or a trail ID for getTrailsById, gets information on those hiking trails, such as difficulty, length, and a little snippet about what the trail has to offer. The other API I used was Weather Unlocked, which, given a latitude-longitude pair, will give the forecast weather over the next 7 days. The new APIs that I wrote for this project, REST APIs, were a login, a user API which can create and delete user accounts, and a Trails API that can save, retrieve, and delete trails associated with a user account. The SOAP API I wrote was Get Trip Gear, which, given a list of trails, will suggest gear to bring on that trip based on the forecast weather around those areas and then the length and difficulty of the trails. So for my demonstration, I will show how I used REI's hiking project to get information on certain trails, and then how users can save those trails to their profile, retrieve them if they want to plan trips later, and then eventually delete them if they decide they don't want to use those trails. So in the latitude box and longitude box, I'll be entering the coordinates for Zion National Park in Utah, and then when I click search, the controller will call the API from Hiking Project, and it will return the top 10 most popular trails in the area. Now, say I want to hike 3 of these. I'll select them here on this page, and then when I paste my authentication token in this box, you get that from logging in, and I click Save Selected Trails. The API will save them to the database associated with the user ID it gets from the authentication token. So I'll click that, and it takes me back to the Search for Trails page. But I want to plan a trip using the trails I've already saved, so I go to the Planning page, and I enter my token again, where it will call the API for retrieving trails, and I can get them from the database here. Note, it also calls getTrailsById after getting the IDs from the database and gets the information. So if I want to hike on Angel's Landing and the Narrows, but I don't have time to do the Hidden Canyon hike, I can select it, and then using my authentication token again, I can delete it from my saved trails. It will do the deletion in the database, and then it'll reload the page again, and you will see I just have these 2. Later on, if I want to plan a trip with those trails, I can select them and click this button, but that's out of the scope of what I want to show right now. So to show how those calls to Hiking Project worked, first I'll show these 2 functions, Get Hiking Routes and getTrailsById. The first of which calls getTrails on the Hiking Project endpoint, the second of which calls getTrailsById on the Hiking Project endpoint. That endpoint is listed in my configuration file, along with the private key associated with my Hiking Project account. Now these functions are actually called, first of which by the controller for search results. So when the user types in latitude and longitude, the search results screen will first call the Get Hiking Routes function and then return it to the user. The other is called in my own APIs when you want to retrieve trails. It uses the get method of the API for trails, and it calls this getSavedTrails function, which will get trails from the database, and then later the associated controller will actually call that function from Hiking Project. So the 2 APIs that I wrote that it showed here were the post method and get method for API trails. The post method to save trails makes sure you have a list of trails you want to save and your token, and it will decode your token and make sure you are who you say you are, and then it will connect to the database and insert rows into the trails table the trail ID is associated with your username. And the get method will, again, as I mentioned before, call this get saved trails function. It'll make sure that you have your token. It'll make sure you are who you say you are. Right here, it'll decode it, and then it'll query the table for trails, and it'll get the trail information associated with your username. Anyway, I hope this demonstration has been useful, and I hope it's helpful as well.